Dear students, welcome and thank you for tuning in for this video. We are continuing our discussion about polymers. This is the last video of polymers. We are going to talk about the different types of polymerization. We discussed in the previous video the chain polymerization or addition polymerization, and we said that monomers has to be able to undergo reaction at chemically the active sites, and also the added monomer has to create an active site for the following monomer to be added. If you look at this schematic, you can see that we have polymers active site and you have the blue dot, which is the electron. We took that the carbon double bond is the one that's going to donate an electron to the left and the electron to the right. The electron going to the left is going to covalently bond with the other RO group and sharing the two electrons, and then the active site is created on the right hand side of the far right, carbon atom, and then the new active site is created, the blue dot, and then more and more monomers will be added to this chain. This is a schematic of how the reaction will take place, the sequential progression and addition of those monomers. So you can see step by step, one monomer after the other, they will be added to create our polymer. So it's a sequential process and repeated process, and that's how we create our polymers in the addition or chain reaction. We talked about starting the chain reaction. So how about ending the chain reaction and terminating the chain reaction? So we have two different ways of how to terminate the reaction. The first one is called combination, and the second one called disproportionation. So in combination, you know that each polymer, we said that the active site has to be reproduced at the end, at the last monomer added to the chain. If you have two polymers, both of them has active sites, these two active sites will combine together and create a new bond, and that's what we call combination reaction, and the polymerization reaction will stop. And this is the end result. Whatever the combination of the two polymers, the polymer chains, is our new polymer. In the other disproportionation termination process, we're going to recreate the double bond by releasing one of the hydrogen atoms. So what happened is that you release from the first polymer chain, the blue one. We'll talk about the bottom half, and the blue chain, it will release a hydrogen atom, and the electron to the right of the last carbon atom to the right will join this electron that's released, and we have a double bond of carbon, and then the hydrogen bond will go down, and then we terminate the active site of the red polymer chain. The idea about termination is we need to stop the continuation of the reaction by eliminating the active site, and it can be done by these two processes. So this is what happened in addition and chain reactions. The other type of reaction that happens in polymers, something we call step growth polymerization or condensation polymerization. We have a byproduct which is H2O, and there are different properties between the two. What's the main difference between addition polymerization versus the step growth polymerization? In addition polymerization, it proceeds by sequential addition of monomers with the preservation of the active site, right? And the step growth polymerization, a growing chain can react with each other to form large chains in non-sequential fashions. And you can see that if you go back to this, we don't have an active site, but we have these atoms that they attract to each other and create the polymer by the step growth polymerization. And they don't have to be sequential in fashion. So you can have one polymer from the middle attaching to the another polymer. We would like to talk about an important concept in polymers, which is molecular weight. If we say that the material that have a particular molecular weight, it means that all molecules in that material has the same molecular weight. However, in polymers, it's a different story. In polymers, the molecular weight is ambiguous because every molecule does not have the same number of monomer units, and it depends on the reaction, the polymerization reaction. So you can have, let's say, polystyrene, and inside the polystyrene you will have, a lot of different polymers with different numbers of monomers, so different change lengths. And that's why it's ambiguous in molecular weight in polymers. However, we keep saying that in order to identify a polymer, you need to know the molecular weight of a polymer and the cross-linking of the polymer. The molecular weight of polymers is not one number because it's impossible to have the same length or the same number of monomers for all the polymers inside your material. This non-uniform molecular size situation arises from the chemical processes and in the synthetic of the polymer, especially in the addition polymerization. You need to make sure that how do you start and when do you stop your polymerization. In the step growth polymerization, it's non-sequential, and it can have different different starting and initiation and termination points. So it's impossible to have a polymer with exactly the same molecular weight for each of the polymers that makes the material. And unlike small molecules, molecular weight is not a unique value. It's impossible to have one value. So rather, a given polymer will have a distribution of molecular weights. So that's how we look at this. Instead of having one value, it's a distribution of molecular weights, and those distribution depends on the process. And for polymers, we should not speak about molecular weight, but rather distribution of molecular weight. And also we can talk about average molecular weight. That's another term, another quantity we can measure. The polymer's physical properties will be function of the molecular weight distribution. And if you look at the schematic to the right, this is a typical tensile testing schematic for a polymer that relates the strength to the molecular weight. So you have the top, the S infinity. This is the maximum infinite strength of a polymer. If you have, and you can look at the curve that reaches to that point, you can see them as if we have small molecular weight to the left, the strength will be very weak and it's not functional. As you increase the molecular weight, the strength will increase, and they will have more application for our polymers. And this relationship can be categorized by an inverse function, S equals S infinity minus A over M. A is a constant and M is the molecular weight. As the molecular weight increase, we're getting closer and closer to S infinity. When the molecular weight is maximum, then we reach the S infinity of the strength of the polymeric material that we have. We just want to understand the basic concept of how to make how polymers are made, and what are the characteristics of polymer, the quantities that we want to measure, and one of them is molecular weight. Thank you for watching, and until the next video. Bye.